Hello students, welcome to EDAMIGO, an initiative by GATE ECE Top 3 Rankers. So I welcome you all to the lecture series on previous year GATE questions on the subject of Signals and Systems, Electronics and Communication branch. Here we are solving the questions and also going through the concepts on which the questions are based. So the topic is basics of signals and systems, and we have already completed 9 parts of the lecture series. This is the 10th part and the last part of the topic. So let's begin with the questions. So this is the first question that we have to solve. So here we have to define the direct delta function, or as we say, the delta function. Okay. Now the delta function, that is delta t, is drawn like this. Okay, as we know, the delta t is present at t equal to 0 on the time axis, and let us draw with the black color. So it is drawn like this with the arrow. So this shows that the location of delta t is t equal to 0, and value at t equal to 0 is infinity. Okay, the value is infinity. Okay, so we say that delta t is equals to infinity at t equal to 0 and 0 t not equals to 0. Okay, it is 0 elsewhere, but this definition is still not complete, because we have to write that the area of delta t is 1. That is, if you integrate this signal from minus infinity to infinity on the time axis, then you will get that the answer is equal to 1. Okay, so now this completes the definition of the delta t. Okay, so the definition will be complete only when you will write these two things: first the location, and second the area. Okay, the area is 1 and location is t equals to 0, and at t equals to 0 the value is infinity. Okay, so D will be the correct definition, that is the area is 1 and location is 0, and at t equal to 0 the value is infinity. Okay, now let's move to the another question. Okay, so these are the impulse responses of the LTI systems. We have to find that which of the system is a causal system. Now as we know that an LTI system will be causal. So what is the condition of causality? Will be causal only when HT is equals to 0. HT is equals to 0 for t less than 0. So this is the condition. HT should be 0 for t less than 0. Okay, now here we can see that this is not satisfying the condition, this is also not satisfying the condition, this is also not satisfying the condition. Only option B is satisfying the condition, and thus only the system having this impulse response given in option B will be a causal system. Okay, so answer is B in the question. So here we have to give the information about the Hilbert transform. Now the Hilbert transformer is actually a continuous time LTI system. Okay, so this is the definition of Hilbert transform. Hilbert transform is a continuous time LTI system, with impulse response HT is equals to 1 upon pi t. Okay, and if we find the Fourier transform, then it is equal to minus j times signum omega. Okay, so it is actually equal to, if I draw h of j omega, it is equal to minus j for omega greater than 0 and plus j for omega less than 0. Okay, so this is h of j omega for the Hilbert transform, and this is ht. Now as we know that it is a continuous time LTI system, it is a continuous time LTI system, so it is a linear system, it cannot be time varying. So it is a LTI system, it cannot be time varying. It is a linear system, it cannot be non-linear. So now we have to find option B and option D. Okay, now if I draw ht, then ht will be like this. ht can be drawn like this. Okay, so it will be like this. Now since we can see that since ht is not 0 for t less than 0, so system is non-causal. Okay, and since we can see that h of j omega is plus j, okay, for omega less than 0 and minus j for omega greater than 0, if I draw the magnitude plot, then it will be equal to 1. Okay, so we can say that it is actually acting as a all pass filter, it is not a low pass filter. So D is also not the answer, answer is B. Okay, so this is how we solve the question. Now let's move to another question. So this is a question and it's a very conceptual question. I will also tell you or explain you the concept behind the question. So here a signal is given and we have to find the average power of the signal. Okay, so the concept behind the question is, suppose we have a signal that is capital XT is equals to A1 cos omega 1t, or let us say A and B. Okay, B sine omega 2t. Okay, now this will be a periodic signal. Okay, so let us say that the period is t0. Okay, let us say the period is, let us say the period is t0. Okay, now the power of xt will be equals to 1 upon t0. So I am telling you a general method. Okay, then I will tell you the general formula and then we will solve the question. Okay, so I am telling you the general method, integration over time period mod of xt whole square dt. So integration over time period, this will give me a square cos omega 1 cos square omega 1t plus b square sin square omega 2t plus 2 times ab sin omega 2t cos omega 1t dt. Okay, now let me write the formula, break the formula. Okay, integration over time period a square cos square omega 1t dt plus b square integration over time period sin square omega 2t dt plus integration 2ab, and this sin omega 2t cos omega 1t will be written as, so this can be written as 1 upon 2 times of sin omega 2 minus omega 1 plus sin omega 2 plus Okay, so I need a space, more space. So I will write it like this. Okay, omega 2 plus omega 1 into t into t bracket close. Okay, dt, integration over time period. Now this will be written as 1 upon t naught integration over time period a square. Now cos square omega 1t can be written as 1 upon 2 1 plus cos 2 omega 1t divided by, so I have already written a 2 outside, so no need of this. Okay, dt. The second term can be written as plus integration over time period b square 1 upon 2 1 plus, sorry, this will be 1 minus cos 2 omega 1t. Okay, so 2 I already written, dt. Okay, now the third term can be written as plus integration over time period 2ab. So 2 and 2 will cancel out, so I will remove t2 here. Now this is sine of omega 1 plus omega 2 t plus sine of omega 1 omega 2 minus omega 1 t dt. Okay, now as we know that this is the time period t naught, which was the period of this signal, okay, where the frequencies were omega 1 and omega 2. Now this signal has frequency 2 omega 1. Okay, now very important point is that since this capital xt is periodic with period t naught, there are two parts, this and this. So a cos omega 1t will have integer number of cycles in this time period. B sin omega 2t will also have integer number of cycles in this time period t naught. Now cos 2 omega 1t. Now since cos omega 1t has integer number of cycles in time period t naught, so cos 2 omega 1t will also have integer number of cycles in this time period t naught. Similarly, cos 2 omega 1t will have integer number of cycles in time period t naught. Sin omega 1 plus omega 2t will also have integer number of cycles in time period t naught, and this signal will also have integer number of cycles in time period t naught. Okay, so this is a very important concept, and since all these signals have integer number of cycles in the given time period t naught, thus whenever we integrate cos and sine integer number of cycles, the answer is 0. So this will give us a 0, this integration will give us a 0, this will give me a 0, this will give me a 0, but there are terms which will give me some answer. So this is the, this is a term that will give me the answer, this is a term that will give me the answer. So we can say that this is equals to 1 upon t naught a square by 2 into t naught plus b square by 2 into t naught. Okay, so the power comes out to be a square by 2 plus b square by 2. Okay, so this is the average power of xt, capital XT, which was a sum of two periodic signals. Okay, now a very important point. Now let us say that, now a very important point first of all, that as we know that a cos omega t plus theta has average power a square by 2. Okay, we know this. Now if capital XT is equal to large number of cos and sine terms, A2, Okay, and so on. There are a large number of terms. Then the power of xt, average power of xt, is equal to the sum of average power of each individual sinusoidal term. So as we know, the power of this will be a1 square by 2 plus power of this will be a2 square by 2, the third term a3 square by 2, and so on. Okay, so this is the concept, and this is a very important formula, that whenever a signal is written as sum of large number of sinusoidal or cosinusoidal terms, then the average power of the signal is sum of average power of the individual signals. So if we go to the question, then this is a signal 8 cos 20 pi t minus pi by 2, 4 sin 15 pi t. So the signal was 8 cos 20 pi t plus theta, so no need of that angle, plus 4 sine 15 pi t. Okay, so let me check that the values are correct or not. Yes, the values are correct. The power of this signal will be equal to the sum of individual powers, that is 8 square by 2 plus 4 square by 2. 8 square is 64 by 2 plus 16 by 2, that is 32 plus 8, that is 40. So 40 is the correct answer. Okay, so A will be the answer to the question. Okay, now let's move to the next question. So this is the next question. Here xn is given to us, and let me write xn is equal to minus 4 minus 5j 1 plus 2j minus 4. Okay, and this is the 0 mark. Now we have to write the conjugate antisymmetric part of the sequence. Now as we know that any signal can be written as sum of conjugate symmetric part and conjugate antisymmetric part. Okay, so xn is equal to xn x minus n conjugate divided by 2 plus xn minus x minus n conjugate divided by 2. Now this is the conjugate symmetric part, that is xcsn, and this is conjugate antisymmetric part, that is xcasn. Okay, so xcasn is equal to xn minus x minus n conjugate divided by 2. Okay, now we already have xn, that is equal to minus 4 minus 5j 1 plus 2j, and the last is 4. This is xn. X of minus n is will be equal to, just flipping the terms, so here it will be 4 1 plus 2j and minus 4 minus 5j. Now x minus n conjugate will be equal to 4 1 minus 2j and minus 4 plus 5j. Okay, now we have xn, we have x minus n conjugate, so x conjugate antisymmetric n will be equal to xn minus x minus n conjugate divided by 2. This will be equal to, the first term will be equal to minus 4 minus 5j minus 4 divided by 2, 1 plus 2j minus 1 plus 2j divided by 2, Okay, so let me write this at the bottom, and the third term will be 4 minus 4 plus 5j divided by 2. So by solving this, we can see that XCASN will be equal to minus 4 minus 2.5j, 2j, 2 minus 5j, sorry, 2 minus, not 2, it will be 4. So it is 4 minus 2.5j. Okay, so this will be the answer, that is XCAS will be equal to minus 4 minus 2.5j, second term 2j, and third term 4 minus 2.5j. So A will be the correct answer according to the solution. Okay, so we have solved this question. Now let's move to the next question. Okay, so here it is given that these are 4 systems and these are the properties. So we have to match the properties with the system. Okay, so for this I will be solving all the systems. For all, we have to find that it is linear or non-linear, time variant or time invariant. Okay, so we have to find this. Okay, now solving for linear and non-linear, I will be solving all the systems, then we will match. Okay, so this will become a lengthy solution, but for clarity I'm just solving all the systems. Okay, so let us solve R1, that is yt is equals to t square xt. Okay, so checking that the system is linear or non-linear, so we'll check this. So for we can say that output t is equal to t square multiplied by input t. Now when x1 t is an input, then output will be t square into x1 t. When x2 t is the input, then output will be t square x2 t. When a times x1 t plus b times x2 t is the input, then output will be t square times input, that is a x1 t plus b x2 t. So this is equal to a times, we can say this is equals to, so this is y1 t, this is y2 t, and this is y out t. Okay, so we can see that y out t is equals to a times y1 t plus b times y2 t. So we can say that this is a linear system because it is following the superposition theorem. Okay, now let's check is the system time invariant or time variant. Okay, now for this our step 1 is to write the relationship between output and input. So the relationship is output t is equal to t square times input t. Okay, so this is the relationship. Step 1 is over. Now step 2, that is the delayed output. So we will find the delayed output by simply replacing t by t minus tau in the whole expression of the relationship. So yt minus tau is equals to t minus tau whole square x of t minus tau. Now step 3, to find the response, that is y dash t of delayed input, that is xt minus tau. So now here the input t is equals to xt minus tau, and using the relationship found in step 1 we can say that y dash t, that is the response of xt minus tau, will be equals to t square times input t, that is xt minus tau. So we can say that since yt minus tau is not equal to y dash t, thus it is time variant. So system 1 is linear plus time variant. Okay, now let me tell you, so this is the method. So the conclusion here is that whenever in a system equation output is equals to a signal multiplied by input, or output is equals to input plus signal, any other signal. Okay, so if these two signals, okay, this signal and this signal are not equal to input, that is they are other than input signal, so it can be a cos, it can be equal to t. So I'm writing that if the signal is any other than input and it is time dependent, then system will be time variant. Okay, so as I have told you the method, complete method, so you can prove this also, and I'm giving you examples for this. So as we have proved yt is equals to t square xt, so this comes out to be, so this is a signal which is time dependent other than input, so this is time variant, this is time variant, we have proved that. You can prove that yt is equals to t times xt, this is also time variant. Yt is equals to xt plus t, this will also be time variant. Yt equals to xt plus cos t, this will also be time variant. Yt equals to cos t multiplied by xt, this will also be time variant. Okay, so all these systems will be time variant. Okay, so this format will be a time variant. But if for example we have yt is equals to xt multiplied by xt, so here the another signal which is time dependent is equal to input, so this will not be time variant, this will be time invariant. Okay, you can prove this using the same method. Okay, this will be time invariant. Similarly, yt equals to xt plus xt, this will also be time invariant. Okay, so you can prove all this. Okay, I have already told you the method. Okay, now let's solve the another question, that is t times mod of xt. Yt equals to t times mod of xt. Now it is visible that we are multiplying t with the input, so this will be time variant. Okay, no need to prove it, I have already told you. Now to check linearity, so we can say that output t is equals to t times mod of input t. So x1t will produce the output, that is y1t, that is equals to t times mod of x1t. x2t will give us output y2t is equals to t times mod of x2t. Now when the input is a times x1t plus b times x2t, then the output will be y out t, that is equals to t times mod of a x1t plus b x2t, and this is not equal to a times y1t, that is t mod of x1t plus b t x2t, because this modulus will not be equal to the sum of individual signals in modulus. So we can say that this is a non-linear system. So R2 is time variant and non-linear. So this is non-linear plus time variant. Okay, no need to prove time variant because the method will be same, and I've told you whenever a time dependent term or signal is multiplied with the input, then it is time variant system. Now let's look R3. R3 is mod of xt and R4 is xt minus 5. R3 yt is equals to mod of xt. Okay, so to check linearity, so we can say that output t is equals to mod of input t. So x1t will produce output, that is y1t, that is equals to mod of x1t. x2t will produce the output y2t, that is equals to mod of x2t. Now when the input is a x1t plus b x2t, the output y out will be equal to mod of a x1t plus b x2t, and this is not equals to a times mod of x1t plus b times mod of x2t. That is, it is not equals to a times y1t plus b times y2t. Okay, so this is a non-linear system. Okay, now let us check time invariant or time variant. Okay, so the step 1 will be output t is equals to mod of input t. Okay, now step 2, to find yt minus tau. Okay, to find yt minus tau, we will simply replace t by t minus tau in this whole expression. So we can get that yt minus tau is equals to mod of xt minus tau. Okay, now step 3. Now the input is input t is equals to xt minus tau, that is a delayed input. Now the response y dash t will be using this relationship that output, that is the response, is equals to mod of input. So y dash t will be equals to mod of input t, that is xt minus tau. Now as we can see that yt minus tau is equals to y dash t. So it is a time invariant system. So this system is non-linear plus time invariant. Okay, now the last system, that is R4, yt is equals to xt minus 5. So let's solve this. We can say that output t is equals to input t minus 5. Okay, so this is the relationship. Now to check linearity, let us say input is x1t, the output y1t will be equal to x1t minus 5. x2t is the input, then output y2t will be x2t minus 5. When input is a x1t plus b x2t, then the output is by simply replacing t by t minus 5 in the input. So this will be a times x1t minus 5 plus b times x2t minus 5. this is equals to a times y1t plus b times y2t. Okay, so this system is a linear system. Okay, now to check time invariance, okay, so step 1 is output t is equals to input t minus 5. Step 2, so to find the delayed output, we will simply replace t by t minus tau in this whole expression. So we will get yt minus tau is equals to x of t minus 5 minus tau. Step 3, to find the output of delayed input, that is input t is equals to x t minus tau. Now using the step 1 relationship, we can say that the response y dash t will be equal to input t minus 5. Now this is input t is equals to xt minus tau. So input t minus 5 will be equals to xt minus 5 minus tau. So we can say that yt minus tau is equals to y dash t. So this is a, so they are equal. So this is a time invariant since y dash t is equals to yt, sorry, y dash t is equals to yt minus tau. So it is a time invariant system. So the last system is linear as well as time invariant. Now you can prove this, that if yt is equals to xt minus b, where b can be anything, then it is a time invariant system. But if yt is equals to x at plus b or minus b, then it will be a time varying system. You can prove this using the same method. Okay, so until and unless you are changing, okay, so let me explain you a point. So this is time invariant, this is time variant. So input was xt. If you are doing shifting in time to get output, then system is time invariant. But if you are doing scaling in time domain, then it will be a time varying system. Okay, so remember this. You can prove this also using the same method. I've already told you the method in an elaborated manner. In 2 and 3 questions, we have already seen this in the lecture series. So this is time invariant. We have proved this. Now you have the homework to prove that this is time variant. Okay, yt equals to x at plus b is time variant. Okay, so now this system is linear and time invariant. Okay, okay, now let me write the results. After solving, we get that R1 is time variant plus linear, R2 is time variant plus linear, sorry, R2 is non-linear, R3 is time invariant plus non-linear, R4 is time invariant plus linear. Okay, so now let's match it. So linear and time invariant is the last one. So P3 is equals to R4. P3 is equals to R4. So P3 is equals to R4. There are two options, A and B. Now time invariant and non-linear. So this is R3. So P2 is equals to R3. P2 is equals to R3 is in option A and B both. Now linear but no, non-time invariant. Matlab means linear and time variant. Okay, linear and time variant. So this is R1. Okay, this is R1. So A will be the answer. Okay, non-time invariant means time variant. Okay, okay. So A will be the correct answer to the question. So I've explained you each and every four systems in a very elaborated manner. So this comes to an end to the lecture series on the topic of basics of signals and systems. So I thank you students, and stay tuned for more lecture series. We will be uploading the whole complete signals and system solutions on the channel. So stay tuned, keep giving us a feedback, and subscribe to the channel, and also share these lectures with your friends and other students who are preparing. So thank you.